All right. Hello, everyone. I'm recording this at 9 at night before, well, tonight, Monday after school. How's it going? So, you may have noticed I'm not in class today. Also, it's not ISD like I told you yesterday. For some classes, that is because I was told like halfway through the day yesterday that we don't have ISD. However, I still have TSIA training all day today. Eh. Anyways, we're going to get started today with some factoring because we can't really slow down. But today should be simple. We have already done some GCF in the past. However, we're going to go back through it. Also include how to factor out what happens if you have multiple x's with exponents. So, let's get started. First, we're just going to start with our warm-up here. Factor x to the fourth power minus 256 using difference of squares. Remember, once you get the answer, check if it can be further factored. We touched on this a little bit if we were talking about the exit ticket. Not all classes did. We're just going to get started with this regularly. We know that. Where's my red? This is my first recording, by the way. So if there are any mistakes or goofs by me, I'm going to keep them in because I don't have time to record this a second time. So let's just kind of start with our regular form here. Now remember, from yesterday, we had the regular form of a squared. What just happened to that 2? Okay, that's a 2. Minus b squared. Why does that not like curves? Is the same as a plus b and a minus b. Sorry, I'm getting the hang of how to use this. A plus b, a minus b. So what we need to do in our first step here is to find out what a is and find out what b is. So we know what a squared is here. Well, we have that from here. This is kind of like our two squares. Remember, difference of squares means you are subtracting two perfect squares from each other. Maybe wondering, wait, is 256 a perfect square? Test it in your calculator. If you are ever unsure, just test it. Promise you it's not that scary. So we got a squared here. Let's just kind of start with the easier one. A squared equals x to the fourth power. Well, in that case, a is the same as x to the fourth power square rooted. If we remember from the other day, x to the fourth power square rooted is x squared, because if you remember, x to the fourth power is the same as x squared times x squared. So we got our a value already. Now let's do b. Our b value here, wrong color. Our b value here is going to be whatever 256 is, square rooted. Okay, I can't write there. See, it's a learning process. All right, where's your writer here? B squared equals 256. We know that for sure because chances are this has an answer. All right, to find out b is we need square root b 256. And if you did it on your calculator, you should have been able to find out it's 16. The square root of 256 is 16. So what that means now is we need to go to our parentheses here and plug in our numbers. We got a. A is x to the fourth power. X to the fourth power, sorry. Oops, I made a little oopsie. Our a here is x squared, because that was x to the fourth power square rooted. X to the fourth power. Same with over here. Now, we remember from the other day, now we can say, okay, well, our b here is 16, so plus 16 and minus 16. Ta-da! All right, so the important bit here, though, is can we go any further? Right, the way difference of squares works is you just need a perfect square subtracting another, even if it is in other parentheses. So look at these two. Can either of them be reduced further? Can any of them be split into a plus b, a minus b? Maybe second. Like 5 of them. 4, 3, 2. I'm bored. It's this one. X squared minus 16. we can actually reduce that again because it is a perfect square minus another perfect square. X squared is a perfect square. We've talked about that yesterday. X times x is x squared. And 16 is 4 times 4. So why can't we do it again? Well, we can. Let's do it. So when we have a third, like when we're doing this the second time, we need to split it again. Our new a here is going to be x. Our new b is going to be 4. So the way we write this as our final answer, just gotta write this down here a little bit. It's gonna be a little squeezed in. Our first parentheses actually stays the same, x squared plus 16, because what's it called? We can't difference of squares it because this is sum. Remember, sum is addition, difference is subtraction. And then we can actually split this one into two different ones. We're going to put x here because x squared can become x. And then we have plus 4 and minus 4. Also, let me keep the plus 16 over here before I forget it. This is your entire answer. It does not just end here. Check, just in case, to see if you can split it again. Our final answer is x squared plus 16 times x plus 4 times x minus 4. All right, so let's go on to our lesson for today. Woo! All right, the greatest common factor. The largest, I'll write that here, the largest, it is hard to write with a mouse. The largest number that can be divided by all terms. For example, find the GCF of 12 and 16. So you may remember this from ages past. We made these kind of t-charts, and what we did is we found the factors of each. And then we were like, okay, what's the largest number they both have? So we can do that real quick if you're ever confused. On the left side, you're always going to put like 1 going down. That's so hard to draw 3. Let's kind of get some more space on this actually real quick. All right, we are going to, man, can I zoom in? Let's find out. I can. Okay. We're actually going to decrease the marker size a little bit. Sorry, I'm experimenting right now. So let us make our T-chart here. And just a small hint, 12 can't go past 3. So we actually don't even need to go any further than that. Over here, we're going to do 16, which I know off the top of my head cannot go past 4. But we'll just kind of go through it real quick anyways. All right, let's kind of start from the top. Remember, the way we do this is 1 times what equals 12? Well, we know 1 times 12 equals 12 because anything times 1 is itself. 2 times 6, and 3 times 4. Can't go any further because 4 would be 3, and that reverses, so you just kind of cut off here. Let's go to 16 now. 1 times 16. 2 times 8. 3 times, well, nothing. 3 times anything can't really... there's no other whole number you can multiply 3 by to get 16. And then 4 times 4. Then the same number pops up twice, so you just stop. So I would say, okay, the greatest common factor. What is the largest thing that they have in common? Factor that they have in common. So let's look at these. We know they have 1 in common. We know they have 2 in common. And we know they have 4 in common. So the GCF, by default, is 4. The GCF would be 4 here. Because it is the largest number that can be multiplied into both of these. Now we're talking about GCF with variables. We are going to take the GCF of the number first. Let me see if I can write this. I'm trying my best. Number first, and any common variables with the same exponent. Now, first, find the GCF of 15 and 20. We're going to do that real quick. Again, do this little chart. And we're going to do 1, 3, And again, I'm just kind of shorthanding this. You guys should know how to GCF by now, I hope. All right, so our factors of 15 are 1 and 15 and 3 and 5. Our factors of 20 are 1 and 20, 2 and 10, and 4 and 5. So GCF here is just the largest number they both have. It's not 15, it's 5. If you ever want to just kind of start from the largest number and go down on one of them, you can also do that. So 5. Let's just kind of, I'm going to write our answer over here in like blue. So we know 5 is the number GCF. Now you need to find out the letter GCF is, or the variable GCF. There's kind of two ways of thinking about this. So we're going to have x cubed, and we're going to have x to the 5th. So if you ever want to think about it, remember, a number to a certain exponent is a number times itself that many times. So we're going to split these a bit. Remember, x cubed is just x times itself 3 times. And then x to the 5th is that x times itself 5 times. So what we're saying here then, saying, okay, how many x's can we take out of both? And yes, most of the time, you just take out whatever is the lowest amount. So in this case, there are 3 x's here. We can take out 3 from this one. So they kind of like cancel each other out, if that makes sense. We're going to do that. We're going to take x cubed out here. And then we are going to, let's go, just find out what's left. So we take x cubed out of x to the 5th power. How many x's are left? Well, 2 of them. So when we take all this out, and what we're going to be doing a lot of today, is you need to rewrite the 2 numbers by taking this out of them. A little further than that. Well, I just gotta make sure we understand right now that when you are taking out a variable with an exponent, you're taking out that many x's out of each of them. So these have x cubed in common. Taking out the GCF is always the first step of factoring. All right, let's try out example 1 together. Factoring out the GCF of 6x squared plus 18x to the 5th power. So the point of like factoring is that we're going to be factoring out these terms from polynomials. We know what polynomials are, we know what terms are, so let's get started out. First, step 1, find the GCF of all terms. So we are going to write this as 6x squared plus 18x to the 5th. So the easy first step is just find out, okay, what does 18 and 6 have in common? Always start with the number first, then do the variable. So we are going to find the numbers real quick. Let's kind of make our little t-charts over here. Nothing too crazy. Some of you may already know this off the top of your head by looking at them, but just to make sure. All right, for 6, we're going to start 1, 2, and for 18, we are going to have, I believe, 3 works. Yeah, that's really all you need. All right. So first, factors of 6. Well, 1 and 6, 2 and 3. They're your factors. Factors of 18, 1 and 18. Because again, 1 times anything is 18. 2 and 9. And 3 and 6. 4 and 5 don't work. And 2 and 3 is actually going to repeat again. So what's our GCF? I'll give you a moment while I change my colors. If your answer was 3, you're wrong. It's 6. Our GCF means the largest available number that they both have. And that, yes, can include 6. All right, so we're going to take that out. We're going to take 6 out of 6, and we're going to take 6 out of 18. What that means is you're dividing. You're dividing both of them by that number you're taking out, which is 6. So we are writing it as 6 parentheses. Oh, wait, no, oops. I'm getting a little too ahead of myself. still is going to be 6 parentheses. We're going to leave a gap here for the variable. 6 parentheses, and then we are going to divide 6 by 6, which is 1. So we're just going to write this here for now. And then 18 divided by 6, which is 3. We're going to leave gaps for the variables when we get there. All right, we're getting there. So we know they divide by 6 first, but now we need to determine what's the variable we're taking out. So the way we figure this out is by saying, okay, we have x squared, and we have x to the 5th power. How do we find out how much to take out of both? Well, it's actually kind of simple. Which one is the lowest one? X squared or x to the 5th power? If your answer is x squared, you'd be right. All you do here is you take out x squared from x squared, and you take out x squared from x to the 5th. So what happens if you divide x squared by x squared? Well, that's just 1. Anything divided by itself is 1. And then x to the 5th power divided by x squared is x to the 3rd power. Why? Well, when we have 5 x's, and you take out 2 of them by dividing them, there's only 3 left. Another way of looking at it too, when you are dividing exponents with the same base, this is just subtraction. What's 5 minus 2? It's 3. 2 minus 2 is 0, yes. That makes it equal to 1. Hey, it's a little strange. I know. I'll explain it more on Thursday. All right. So, what we are doing here in the end is we are dividing both of these terms by 6x squared. We're dividing both of them by 6x squared because this is what they have in common. This is their GCF. Their GCF is not just 6, it's not just x squared, 6x squared. So if you divide 6x squared by 6x squared, you get 1. If you divide 18x to the 5th power, well, you get 3, because 18 divided by 6 is 3, and you get x cubed, because x to the 5th power divided by x squared is x cubed. Our final answer is 6x squared. I'll write it like a little clearer, just like in black. We're going to have 6x squared times 1 plus 3x cubed. And that's our final answer. You take what's largest between them, you just divide it out of both. So we're going to go to example 2 now. And let's start this out. Again, step 1 is just find GCF. Step 2 is going to be divide by GCF. And step 3, put outside of parentheses. All right, let's get started with this one now. So we're going to start with negative 8x and positive 16. So when we have something like this, negative 8x plus 16, what we need to do is you just take out whatever the first number is. So the first term is negative, take out negative from both. So let's just start from here. Let us find the GCF of 8 and 16. All right, first we're going to find the GCF of 8. All right, so remember, 1 times what is 8? Well, 8, 2 times what is 8? 4. 3 doesn't work. And we go to 16. 1, 2, because 3 doesn't work here. 1 times 16, 2 times 8, 4 times 4. Now, first, before we go into the negative stuff, just identify what is the largest number both of them share. You've spotted it. Great job. It's 8. It is 8 for both. So, now what we're going to do is we're going to take that number and we're going to divide each of these terms by 8, but not just 8 this time. I'll actually make it a little clearer in here too. We're not dividing by 8. If the first term is negative, divide by the negative version of that number. So we're dividing each by negative 8. So when we do that, we're going to put negative 8 on the outside of the parentheses here. Times, and then what's negative 8x divided by negative 8? Well, these cancel out. X. And then 16 divided by negative 8, well, that's negative 2. Remember, positive divided by negative is negative. So you may be asking, Mr. Harrow, why did we not take an x out? Well, keep in mind, for it to be a common factor, both of them need to be multiplied by x, not just one of them. So we cannot take x out of both this time. So this is our final answer here. Negative 8 times x minus 2. All right. So before we head on to group work, I hope you guys are treating this up right. We are going to do numbers 1 and numbers 2. Let's start with number 1. Number 1's pretty easy. Actually, number 1 is pretty easy. I think you guys could do that, but I want to be able to help you guys with problems that might be a little bit more tricky. So actually, together, we're going to do numbers 2 and number 4. You guys will be in charge of finishing the rest. And yes, you may have noticed number 7 into x method. We'll have to do x method for number 7. I might actually go over that one as well. All right, let's start with number 2. First, let's just kind of identify our terms here. We have x cubed and we have negative 5x squared. First, kind of identify, is there a number that we need to find a GCF for? The answer here is no. Keep in mind, you only need to do the number part of this, like the 6 for all this, or either of these, if both of them have a number. We don't need to find the GCF of 1 and negative 5, so we actually just go on to the variable step. So what we want to say is, what is the greatest common factor of x cubed and x squared? I'll give you a moment. If your answer was x squared, great job. Just pick whatever the lowest one is. Since x squared is our lowest exponent of x, just divide by x squared on both of them. So that means this will become 1. And this, well, that is going to become x. Again, treat it like subtraction. 3 minus 2 is 1. X to the first power is just the same as x. So we're going to do that now. So, I guess to make it also a little bit clearer too, if you divide here, let me actually rewrite this one a little bit too. So I'm saying x squared divided by x squared is 1, right? Well, what if it's negative 5x squared? Well, x squared and x squared just kind of cancel out. This becomes negative 5. So our new GCF here is going to be x squared, because x squared is all we can take out of both of them, times, well, x cubed divided by x squared is x to the first power, or just x. That's where we get this from. And then for our other one, negative 5x squared divided by x squared is going to be negative 5, just without the x squared. We took it out. It's out here now. This is our final answer. X squared times x minus 5. All right, we're going to do number 4 now. First, find our two terms. Well, negative 27x and positive 18. First thing you can recognize, you don't need to take x out of both. This one's the only with an x, so we only need to take out a number. So let's do that. Let's go through our 2, negative 27, and positive 18. All right. For negative 27, we have 1 and 27. 2 doesn't work. 3 times 9. And I don't think 4, 5, 6, the other one, or 8 work. So we just are going to have 1, 27, 3, and 9. And then for 18, we are going to have 1, 18, 2, 9, 3, 6. And I don't think the other ones work. Now we are going to just find out our GCF is here. Our GCF in this problem, just look for the largest number, is 9. So we need to divide by 9. Not just 9, though. For each of these terms, we need not just divide by 9, we need to divide by negative 9. Because again, remember what we were saying earlier before. If the first term is negative, take out the negative. Since our negative 27 here is negative, just take out the negative. It's negative 27 divided by negative 9. Well, that is positive 3 and x. 18 divided by negative 9 is negative 2. All right, and there we go. That was actually it. That's the entire problem. Ta-da. All right. So how much time has this been going on? 27 minutes. Okay. I think I have time to try to help out you guys with number 7. And then you guys are going to finish this work and then show me on what day is today? Tomorrow's going to be Tuesday. So Wednesday. Yeah, you show me on Wednesday. Hopefully we can continue this lesson and I'll hopefully be able to answer some misconceptions. So you may notice for 7 and 8, we have more than one term. So we're going to find out what they all have in common. And let's make this last one purple. All right, when you find the GCF of 3 different numbers, all you have to do is find out, do they all have a GCF in the first place? First, x cubed, 5x squared, and 6x. Do those share a number in common? And keep in mind, the number invisible next to x is 1. I'm going to kind of cut your phrase here a little short. No, they all don't have a number in common. 5 and 6 don't have one in general, and 1 you can't split. So, no, we cannot take a number out of all 3 of these. We can take an x, though. So what is the x that they all have in common? If you remember from earlier what I was saying, pick the smallest x factor. So right here, if we had x to the 5th x squared, you chose x squared. If you had x squared and x cubed, you picked x squared. Here we have x cubed, x squared, and x. So what that means is all 3 of them have x in common. Because keep in mind, this is just x to the first power. So out of all 3 of these, we are going to divide by x. I'm just going to go red in here. There we go. Divide by x in each of these. So we're taking this x out. We are now going to just divide each of them by x. So it's x cubed divided by x. Well, that's x squared. What's 5x squared divided by x? Well, that is positive 5x without the squared. And 6x divided by x is just 6. So you may be wondering, oh, hey, are we done now? No. This is going to pop up in the test as well. At this point, you are not done. What you have to do now is factor again using x method. I know, everyone's favorite. So we're going to go through that real quick. If you noticed, we have our a, b, and c values. If you remember those, a, b, and C. Our A value here is 1. It's not X, it's 1. Our B value is 5. Our C value is 6. So in the top, we always put A times C. And the bottom, we put, oh, that was a really weird looking C. The bottom, we put B. So first, A times C is just 1 times 6, which is, well, 6. Our B value is going to be 5. All right. From there, we need to find the factors of 6 that add up to 5. So we're going to have 1 and 6, 2 and 3. Remember, these are factor pairs, so you kind of pair them up. Do 1 and 6 add to 5, or do 2 and 3 add to 5? Well, it's 2 and 3. A different color for these. Let's go with like, that's not red, that's orange. Whatever. We're with 2 and 3. All right. So from here, you may be thinking, oh, wait, the answer is -2 and -3. That's not what we're doing here. We're factoring. And I'm going to go a little more into this on Wednesday. Well, the way we were going to do this now is, if you vaguely remember, we talked about this a little bit. So, this is solely orange. All right. So we keep this x on the outside. And on the inside, we are changing it to x plus 2 and x plus 3. If you may remember, there's that one step where you had to divide by a on both these, if you remember that. However, since a is x squared, we're dividing by 1, so that doesn't really change much. If you also remember, you put your a value here, and then your 2 here, your 3 here. Your full answer here is x times x plus 2 times x plus 3. All right. Well, I hope you guys have a great rest of your day. Please finish this work. Please turn it in. Not turn it in. Well, turn it in if we typically turn in work. For the most part, all of you guys are going to be holding on to this. I'll check it out on Wednesday, and I hope you guys have a great rest of your day. If you guys see me around the school, you can say hi. Go for it. I doubt you will, though. I don't know. We'll see. See you guys.